and welcome back to my channel. So today we are going to talk about exponential functions. So what are those exponential functions? Well, they look something like this. So if I have a function which looks like a raised to the power x, a being any number and x is a variable, so this is called an exponential function, and x here is known as the power or the exponent. And a is known as the base. So here this function represents a function that is always increasing. So here we have some rules which you have to follow. A cannot be 1 if it has to be an exponential function, nor it can be negative, right? It cannot be negative and it cannot be 1. So x can be, let's see the domain of this function, right? We have function of x equals a raised to the power x. Now let's say a is equal to 2, right? And let's start with negative in x, so we have 2 raised to the power minus 2, which gives us 1 by 4. And if we increase it, 2 raised to the power minus 3, which gives us 1 by 8, right? So let's say x is in positive, so 2 raised to the power 2 is 4, and similarly to the power 3 is 8. So this gives us some idea about the domain. Let's say x can be negative as well as positive. So domain or the input x is the input. So if you make a graph of this function, let's say this is the graph, right? And so this y represents the value of the function and x is the input. So here we have positive infinity. So as you can see, if x tends to be in the negative, the more it tends to be closer to 0. The more higher power in the negative, it tends to be 0. But the value of the function never touches 0. It tends to be 0. It is very close, very near to 0, but not actually 0. So the graph will look something like this. And here it is touching at this point, which will always be 0, 1. So 0 is the value of x and 1 is the value of the function. It is because if 2 raised to the power 0 or any number raised to the power 0 is equal to 1, so therefore a cannot be less in negative, because if a, let's say if a is in negative, so minus 2 raised to the power 2, which is even, will be 4, but minus 2 raised to the power 3 will give us minus 8, right? So we can see that we are getting, sometimes we're getting positive and we are getting negative. So it's not truly an exponential function. Exponential function should be ever increasing. So it is continuous. Exponential function should be continuous. So we can see if x is tending towards minus infinity or towards negative numbers, the value of the function tends to 0. So that means this portion is getting closer to 0 as we go along this line. So as the value of x is coming towards the positive, the value of the function is increasing exponentially. So let's say this is only valid if a is greater than 1. Now as I said before that a can be only positive number, it cannot be 0, sorry, it cannot be 1. What about when a is in between 0 and 1? So when a is between 0 and 1, so the graph will look something like this. We have the y-axis, which is the value of the function, and we have the x-axis, right? Okay, so the graph of the function will be decreasing and it will be coming closer to 0 if we increase the value of x. So let's see an example. If we have a equals 1 by 2, right, it is between 0 and 1. So if I have the value of x, let's say if I have value of x as -2, so it will give me 1 by 2 minus 2, right? So this will be equal to 4, which is increasing, right? But what if I have 1 by 2 raised to power 2? So that will give me 1 by 4, which is actually closer to 0, right? So it's the opposite. If we have x in negative, the value is increasing, but if we have x in positive and increasing, the value is decreasing and is approaching 0. That's why the value, this function, this graph is tending towards 0. So from this we can see the domain and range. Domain, or the inputs of the exponential function, can be the domain is -infinity to infinity. It means that the input that I'm giving, input in place of x, can range from -infinity to infinity. As we have seen before, that x can be negative or positive or anything in between. It can also be 0. So anything raised to power 0 is 1. So it can be 0, it can be negative, positive, everything. So this gives us the input, the range of inputs. That is the domain. What about the range? What about the outputs? What is the range? So as we can see, the range is from 0 to infinity. I have kept it open brackets. That means 0 is not counted. Anything after 0 is counted. So the range or the output will always be greater than 0 towards positive infinity. As we can see before, that even with negative powers of x, when x was negative, we were getting positive answers, right? The value of the function was in positive. Therefore the output will always be in positive and will be greater than 0. So let's see some of the properties of exponential functions. Like we have, let's see, if we have a raised to power x and is equal to a raised to power y. So when we have such a case where we have same bases, the base is same, that means, so this right hand side can, the left hand side can be equal to right hand side when we have 5 things which are followed. So 1 is when x equals y, then this is true, right? The second part is when a, or the base, is equal to 0. If the base is equal to 0, anything raised to power 0 will be 0. So that's why these two can be true when a is equal to 0. And again, when a is equal to 1, these two are similar, are same. And again, when a is equal to minus 1. So this part can only be true when both x and y are both even or both are odd. Okay, so we have to take care of this rule. When the base is minus 1, this will only be satisfied when both x and y are even or odd. So this completes the introduction of exponential functions. In the next video, I'm going to talk about logarithmic functions, and then we are going to move towards the derivatives of exponential and logarithmic functions. Thank you for watching.